In this video, I have taken up parallel connection of networks. I've already done a video on series connection of two networks and how to obtain the resultant parameters of a resultant network which is obtained after paralleling two independent networks. That is the objective of this video. Okay, so we have network A and network B. It is simple. We have two port networks. We have network A with the input port. This is the input port and this is the output port. Input port parameters with their positive directions of measurement of voltages and currents, and this is the output port with the positive direction of measurement of current and voltage. Okay, correspondingly this is network B with similar parameters, input port, output port, and their parameters. Now what we are trying to do is we are trying to parallel the two networks. We are trying to connect the two networks in parallel. So what do we mean by connection of the two networks in parallel? So I will connect from 1 and 1 dash the resultant network. I'm connecting it to this as well as this port, this terminal. Okay, so I have connected this and 1 dash to 1 dash of the first network and 1 dash of second network. So this is my parallel connection. Similarly, 2 of the overall network is connected to the terminal 2 of the network A and also to the terminal 2 of network B, and here it is again connected in similar fashion. This is my parallel connection. Now what I get is, I'll take a different color. Now what I get here is a two-port network. I only hope I get a good square. Okay, now I'm able to get a decent two-port network. Right? I'll shrink this a bit. Why can't I shrink this a bit? I'm trying to reduce the external box. You know, the size of the external box, instead of getting reduced, it's bloody moving. What do I do? Can I not pull this corner in? Okay, I'll reduce this first and then take it here. Okay, this is the best I can get. Anyway, this is how I get the overall network. Okay, I'll clear this 2 and 2 dash and clear this 1 and 1 dash, and then I'll try to fix this little here. Okay, what I mean is now I've got parallelly connected two networks with this as 1 and 1 dash, 2 and 2 dash. This is the overall network that has resulted in, and this is my V1, this is my I1, this is my V2, and this is my I2. So I'm able to get a network which has resulted out of connecting network A and network B in parallel. We know how to connect networks in parallel. We know how to connect any two elements in parallel, right? So we have done it. I suppose this is very clear. So what we try to do now is we try to get the overall Y parameters of the network. It is easy. Okay. So what we do is we will try to get the Y parameters of the overall network. So in Y parameters, what do we understand by Y parameters? V1 and V2 are the independent variables and I1 and I2 are the dependent variables. We are trying to express I1 and I2 as a function of V1 and V2. Okay, now where do we have V1 and V2? V1 and V2 are the input port voltage and the output port voltage which is available to us after paralleling these two independent networks. So we are trying to get this relationship of this overall network. Alright, I suppose it's clear. Y parameters? Why not any other parameter? It is because it is easy to obtain Y parameters when two networks are connected in parallel. Like how we have Z parameters to be a convenient set of parameters when two networks are connected in series. Y parameters are easier to obtain when two networks are connected in parallel. Okay, when two networks are connected in parallel, it is easy to obtain Y parameters. So and if we are interested in, let us say, ABCD parameters, from Y parameters we will get ABCD parameters. That's what I'm trying to say here. Alright, now our objective is to obtain Y parameters of this particular combination or of the resultant network, right? So we will try to do it step by step like how we did it for Z parameters. You can watch my previous video for this and you will know how to do that. Okay, so how to get the Y parameters. So we will try to write. I will not look at the network now, and it is not very important for us to have the network right now. For network A, what can we say about the I1 and I2? So we know I1 equal to Y11 I1 plus Y12 I2, and this is for A network. A network I have written in yellow. Let me try to use the color. Okay, this is how it is. Now I'll try to write the other equation. What is I2 equal to? I2 is Y21 I2 plus Y22 I2, and this is for A network. So I'll try to put this as A network. Okay, this is for the A network. Now what is it for B network? Similarly, we can get the equations for B network. What I'll do is I'll try to take this entire set itself. This I'll copy. I'll paste it here. And I'll try to make use of, I'll try to remove all the A's from these sets of equations and I'll try to replace by B. This is for A network I have written. Now I'll write it for B network. For B network, it's again I1B is Y11B, I1B plus Y12B, I2B, I2B equal to Y21B, sorry. Oh, I'm so sorry. This is a very, I'll try to take white. This is Y11 V1, Y12 V2, this is V1, this is V2, V1, V2. My fundamental equations were incorrect. This is V1, this is V2. That is a blunder. For B network, okay, B, B1, B, 2B. Okay, so I1, I2 are expressed in terms of V1, V2 via Y parameters. I suppose the equations are okay. So for A network and for B network, we have written down the equations independently, right? So, and similarly, we have for the overall equation, overall network. For overall network, we can write the equation as I1 equal to Y11 V1 plus Y12 V2 and I2 equal to Y21 V1 plus Y22 V2. So, we can get that. Okay, we will try to have that little later. Anyway, this is for A network and this is for B network. So, what can be observed from this network configuration? If you look at this network configuration, it is easily visible, or it is very evident that V1 is the voltage between these two terminals, which again are appearing between the two input terminals of network A and network B respectively. The voltage that is available between 1 and 1 dash, that is V1, is also the voltage between 1 and 1 dash of A network, 1 and 1 dash of B network. I suppose I'm not wrong in saying so. Similarly, if V2 is the voltage between 2 and 2 dash of the resultant network, the same voltage, if you can see the network, if you can see the same voltage between 2 and 2 dash is also appearing as V2A, and that is same as appearing as V2B. So we can simply say V1 equal to V1A is also equal to V1B. V2 equal to V1, V2A and V2B. It's very easy to comprehend this information. isn't it? And secondly, that is one thing. We will write it eventually. I'll write it down. Secondly, the current I1 that enters this particular terminal or node will split into two, that is I1A and I1B. In other words, I1 equal to I1A plus I1B and I2 equal to I2A plus I2B. These are the two important observations that one can do by inspection. Okay, so we will try to write those relationships. Okay, from inspection, what I mean is V1A equal to V1B equal to V1. This is one relationship. And V2A equal to V2B, which is V2. This is one relationship. And another relationship is the overall current I1 can be seen as the combination of these two currents, that is I1A plus I1B, and the current I2 is the sum of the two currents I2A plus I2B. In parallel combination, it is the voltage that is equal, okay, and the current would split. So the whole split, right? This is simple parallel connection. Now what do? It is very simple. I will name these equations. This is my 1. This is my 2. This is my 3. This is my 4. Okay? And I will try to make use of these things. We can further name them. This is equation set 5. This set is 6. Okay? I'll try to take this set 6, substitute in 6 in this set of two equations in this set. I'll try to substitute for I1A and I1B, I2A and I2B from 1, 2, 3, 4. Okay, so in equation 6, I'll try to make use of 1, 2, 3, 4 and rewrite equation 6. Okay, so we will try to rewrite equation 6. Rewriting equation 6 using equations 1, 2, 3, 4. 1, 2, 3 and 4. Okay, we will try to do that. We'll try and do that. These derivations are, quite interesting to do. The purpose of doing derivations is that the concept gets consolidated. The understanding would be much, much more better, and the result you tend to remember if you have done the derivation. That is the only advantage. Alright, so I'll make use of these equations and then try to obtain. What is my I1 equal to? I will write I1 equal to my equation, set of equations. I'll try to get an equation for I1. I'll try to get an equation for I2. So I1 equal to I1A. What is I1A? I'll try to make use of equation 1. Okay. So I1 equal to equation 1 I have to write, right? So Y11, it is Y11 I1. I'll try to put the suffixes little later so that I won't make any mistake. I12, sorry, why I'm stuck with I1, I don't know. Y11 V1 plus Y12 V2. Okay, this is for equation 1. For I1A plus I1B. For I1B, I have to make use of equation 3. So equation 3 would be this plus Y11 V1 plus Y12 V2. So I have to substitute properly. This is of A network and this is a B network. All right, this is okay. Now, what is I2 equal to? I2 is the sum of the two currents, that is I2A and I2B. What do I do for I2A and I2B? I2A and I2B, I'll pick it from equation 2 and equation 4. Okay, so I'll write this equation. So I2 equal to Y21A V1A plus Y22A V2A plus this is 21A and this is Y22B V1B plus, I'll put B with color, that's why I'm just mentioning, I'll make use of the color. This is of A network and this is for B network. Okay, so I'm able to get the relationship between V1 and V2. Okay, now on the right hand side I should have V1 V2, I1 I2 on the left hand side, I have to have V1 V2 on the right hand side. So what do? I will now make use of relationship 5. Okay, I'll make use of relationship 5. So using 5, what I do is wherever I have V1A, so what I'll do is I'll pick up these equations. Okay, I'll pick up these equations, rather I'll copy this equation. I don't know whether I could copy it or not. I would copy, I would paste it here. So what I do is from equation 5, wherever I have V1A, I'll replace it by V1, V2A is by V2, V1B is V1, V2B is V2, V1A again is V1. I'm just removing this subscript. This would be okay. I have made use of equation 5. What is equation 5? Equation 5 is V1A equal to V1B equal to V1. This is what I have done. Okay, and our V2A equal to V2B equal to V2. This is what I've done. I just removed the suffix A, suffix B, suffix A, suffix B from V's. Then I've just maintained V1 and V2. That's all. Okay. Now, I suppose there is no confusion and there's no ambiguity here. So now what is I1 equal to? So I1, if you can group the terms, I1 equal to Y11A plus Y11B. This whole thing is V1 plus Y12A plus Y12B of into V2. Okay, and I2 equal to Y21A plus Y21B into V2 plus Y22A plus Y22B into V2. Okay, this is done. We are done. These are the relationships we are interested in. Okay, this is the relationship we are interested in, isn't it? So it's very clear. Now for the overall network, if we can write for the overall network, so for the resultant network, for the resultant network, if we can write I1 equal to I11 I1 plus y12 I2. Sorry, where is it? Why is it I'm writing? Oh, y11 v1 plus y12 v2 and I2 equal to y21 v1 plus y22 v2. If we can compare these two sets of equations, this set these two, if we can compare, we can easily say that y11 equal to, so overall y11, if I can write y11 now equal to y11a plus y11b. I'll put the colors. This was my A, this is for my B. Okay, similarly we can write the other things. I will first write and then put the suffix. Okay, so y12 equal to y12a plus y12b, then y21 equal to y21a plus y21b, and y22 equal to y22a plus y22b. I'll pick the colors and put this is A, this is of A network, this is of A network, and for B network I have of B network. Okay, so we are able to get the overall parameters. This is y22, this is y22, and there ends the derivation. That means if the two networks are in parallel, it should be easy to write the y parameters of the resultant network, because the overall y parameters is found to be equal to the sum of the y parameters of the independent networks. All we have to do is, if we know the independent y parameters of the independent networks, we can add the two directly and then obtain the overall y parameters. So the inference is that when two networks are connected in parallel, try to obtain y parameters. How do you do it? By simply adding the y parameters of the independent networks. Okay, I suppose this derivation is easy to understand, easy to comprehend. It is simple series parallel, and most of the electrical engineering things revolve around series parallel, star delta connections. The various connections are that simple, and RLC parameters and voltages and currents. That's all there is to it. Anyway, thanks for your viewership. Hope you understand this network in parallel connections of networks. Previously, in my previous video, I had done series connection. Now I have taken up parallel connections. There is one more kind of important connection, that is what we call as there are series, parallels. Those are all complicated connections. But then we have what we call as cascade connection. That is another interesting kind of connection, wherein instead of y parameters and z parameters, we talk about ABCD parameters or transmission parameters. Anyway, I'll stop this video here. Thanks for your viewership. Let's try to see in the next video. Let's meet in the next video.